Hello friends, this video on differential equation part 13 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 12. Now let's understand homogeneous function. Why we will understand this is because if the function is homogeneous, it is easy to solve. So we'll tell how to solve homogeneous functions. But before solving homogeneous function, let's understand what is homogeneous function of degree n. A function is said to be homogeneous function of degree n if this is my function in terms of x and y, lambda x, lambda y, that is equal to lambda to the power n into fxy, right, where lambda is any non-zero constant. So this kind of function is called homogeneous function of degree n. So let's take some example. For example, I have this function 1 y square plus 2xy, correct. So in this case, if I can write f of lambda x and lambda y, nothing but lambda y square plus 2x becomes lambda x, y becomes lambda y. Why? I'm replacing y with lambda y, x with lambda x, right? So this becomes, actually, if you see, lambda square into y square plus 2xy, correct. And y square plus 2xy is what? F of xy lambda square. So if you see, my f1 lambda x comma lambda y becomes lambda square into f1 x comma y. Thus this is nothing but a homogeneous equation of degree 2, correct. What I've done, I was given f1 xy, I found f1 lambda x lambda y, I found that this guy is nothing but lambda square into f of xy. Let's take an example, y plus 2xy. So if I find this, if I take f2 of lambda x lambda y, this becomes lambda y plus 2 lambda x lambda y, right? And if I take lambda common, this becomes y plus 2 lambda xy. 2 lambda is extra here, so I can't even write this is nothing but lambda into fx. I can't write, right? So this is not a homogeneous equation. And please note, the equation looks simple. The only thing is here was y square, here it becomes y. So if you want to find the homogeneous, the equation is homogeneous or not, in the first look, what you can do, you check the power of all the variables. Here it is 2 y square, xy, x into y 2, here it is y 1 power, here it is 2 power, right? So the power is not constant. The power is constant, that equation is generally a homogeneous equation. That is a shortcut to find, and that's the reason why I took this example also. In this case, the power is 2, power is 2, power is 1, power is 2, right? So the power is not same, so it is not a homogeneous equation. In this case, both are 2, 2, so it is a homogeneous equation of power 2. Let's take another equation. If you see here, the power is 1, here also power is 1, so it is a homogeneous equation. We know that. Just to confirm, what I can do is I can write f3 lambda x lambda y is nothing but 2 lambda x minus 3 lambda y. Lambda common, this becomes 2x minus 3y, right? And this guy is nothing but f3 xy. So if you see, f3 lambda x lambda y is nothing but lambda into f3 xy. So this guy is of power 1, power 2. The next is f4 sin x plus cos y. So if I put find f4 lambda x lambda y, this guy becomes sin lambda x cos lambda y, right? I can't take lambda common, so I can't write in that fashion lambda power n f of xy. So this is also not a homogeneous equation, correct? So with this, I think it must be clear to you what is homogeneous equation. The power is always constant. It's 2, here it's 1, right? And I can write f lambda x lambda y as lambda to the power n f x y, where n is the degree of the homogeneous equation. There's one more view for that. homogeneous equation, the view says that if my fxy is a homogeneous function, if my f of xy is nothing but x to the power n gy by x or y to the power n some function h x by y. So in that case also we say that my function is a homogeneous equation. For example, the same equation I can write if you take y square common, right? This becomes 1 plus 2 x by y. And this if you take x square common, this becomes y square by x square plus 2y by x. So if you see, this guy is some function in x by y, and this guy is some function towards g in y by x. Correct? So I wrote this guy as y square into some function in x by y form, and this guy I wrote as x square into some function in y by x form. So I can say that this is also homogeneous equation. The funda is same, the only the view is different. In this case I can write example in y form. If I write y into 2x by y minus 3, if I write in the form of x, 2 minus 3 by y by x. So if you see, y into some function in terms of x by y, x into some function y by x, right? X to the power n gy by x or y to the power n h x by y. Cos x by y. So I mean there is no degree in this case. So having understood the two view of homogeneous equation, you see this is a homogeneous function actually. We now know homogeneous function. Now we'll know homogeneous differential equation. So a differential equation is called homogeneous if my fxy is a function of degree 0. So if this is my homogeneous, or this is my differential equation, because dy by dx is equal to fx, this is called a homogeneous differential equation if this guy is a homogeneous function of degree 0. Please note, for example, cos x by y, the degree is 0. Why? This is lambda to the power 0 into cos, because I'll show you f of lambda x lambda y will be cos of lambda x by lambda y. That will become cos of xy itself, right? So there is, here you have lambda to the power 0. So this kind of equation, right, where you have the degree is 0, this guy is called homogeneous function, right, hf of degree 0, and the whole thing is called differential homogeneous equation. So please understand the difference. When you talk about homogeneous function, this guy is a homogeneous function, right, of degree 0. So a differential equation of form dy by dx is equal to fxy. If fxy is a homogeneous function, please note fxy is a homogeneous function of degree 0, then this whole thing dy by dx is equal to fxy is a homogeneous differential equation. And we have a special way to solve such kind of. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.